All right, everyone. Now we did our proportional controller, so now let's add a derivative controller. So we have a proportional gain. Now we have our derivative controller. So this is, you can kind of think of it as like this velocity dependent term in the example of the spring mass damper system. And it's going to basically serve to effectively increase the damping of the system. So KD is going to increase the coefficient. The poles now are going to move left. So it's going to be more negative real as we increase. It's going to move down in the imaginary axis. Our damping ratio increases, less oscillation. Sigma increases, faster settling time, and essentially more robust values. It's basically like adding another physical damper in the system, and the system is going to converge quicker. So with this proportional and our derivative controller, we're going to have independent tubing over both stiffness now and damping. So it's a very effective way to control, design essentially a controller system. So our transfer function becomes this. We can kind of see what are the terms in that denominator now. And you can kind of see we're going to solve for here. And looking at the poles, you see, as I increase that derivative control, exactly like we said, the real poles shift left. I'm changing essentially that natural frequency now with this derivative controller a bit. So my damping, my C effective now is this plus this. My K effective is this plus this. So the proportional controller increases stiffness. Damping increases with KD. So you can kind of see that reflected in the poles as well. So more damping poles will move leftward, increasing the more stiffness. Independent control over these two things. So really, really, really cool. So, and actually you can kind of see that reflected in the terms as well. You see we're increasing simply that damping ratio with this derivative controller. So we have improved response speed, increased dampening, settling time decreases, better transient. There are some limitations. So there's no integrator. We have a type 0 system, so our steady state error can persist. High frequency noise. There's a 0 that's now introduced. There's 2 degrees of freedom, so you have to balance those. But you can shift those poles to get good responses. So adding that integrator is a way to improve that steady state performance, but it's a really, really effective control technique. So let's go ahead and actually let's see some of the system responses. So if we go to PD control here, PD control is now going to give us this. So now we have the GS that looks like this. I'm just going to pull that out. Still second order, so we should still see 2 of our two poles. And now we can kind of see what happens in our system. Actually, I want to pull it like this. So, and I can say, let's vary now this system. So we can actually see kind of the response. And let's just kind of independently change things. So just like last time, right? So if I have, let's look at it. Let's look at it here, and let's look at essentially the system response here as well. And I'm going to kind of pull these values out. So right now we have this response. Again, we are stable, and we can see that reflected in the system. If I increase my proportional, remember that actually leads to more oscillations, right? More oscillations in our system, just like what we saw previously. And over here we see if I increase here, all that's changing is that y-axis, right? I'm not changing my x-axis. Actually, I am proportional control, excuse me. But basically it's kind of changing here. So I'm getting more oscillations there. Now, if I increase my damping, you see here, you see how the poles are moving more to the left? And there's a point where I actually can become unstable, so we've got to be careful about that. But you see, as I'm increasing that derivative term, so for example, I increase the derivative, you see, I'm damping those oscillations. What a beautiful response. So that's where you can essentially see where the systems are looking at. Now, you can kind of see that response, but there's also going to be values, again, where you got to be careful where you can switch to undamped or so just be careful as you change those parameters. But that's exactly what we saw. So Better damping, pulls move further left, fast settling, smoother, less overshoot. So next time we're going to get into integral controller. See you then.